Okay, number 2. Calculate 3.4 times 10 to the power of 9 minus 4.65 times 10 to the power of 8. Give the answer in standard form. Okay, to solve this question, we can use two methods. Okay, first method. (3.4 times 10 to the power of 9 minus 4.65 times 10 to the power of 8. Okay, now we are going to make 10.8 as the common factor. Okay, we have to change 3.4 to 3.4 times 10. Okay, and times 10 to the power of 8. Okay, 10 times 10 to the power of 8 equals to 10 to the power of 9. Okay, so we just change the form. Okay, from 3.4 times 10 to the power of 9 to 3.4 times 10 times 10 to the power of 8. So 10 times 10 to the power of 8 equals to 10 to the power of 9. 3.4, 3.4. Okay, the second term we just copy. Okay, now we can factorize 10 to the power of 8. So this one equals to 34. 3.4 times 10 means we move decimal to the right one step. So 34 times 10 to the power of 8 minus 4.65 times 10 to the power of 8. Okay, now we can subtract. Okay, 4.65. Okay, times, okay, common factor 10 to the power of 8. So simplify this, we will get 29.35 times 10 to the power of 8. 29.35 is not a standard form. So we have to move the decimal to the left one step. So 2.935. Okay, when we move one step to the left, we have to multiply by 10. So we will get 29 again. This one just follow. Okay, by using index law, so 10 to the power of 1 times 10 to the power of 8. So same base, we can add the index. So 1 plus 8 equals to 9. Okay, this is by using the first method. Okay, now by using second method, we are going to make this term to 10 to the power of 9. Okay, 3.4 times 10 to the power of 9 remain the same. So minus this one, we are going to change to 10 to the power of 9. So times 10 times 10 to the power of 8. So this one we should move to the left one step. So 0.465 times 10. So this one will get 4.65. So we can check. So 0.465 times 10 equals to 4.65. This one just copy. Alright. So now we have 10 to the power of 9 as a common factor. So 3.4 times 10 to the power of 9 minus 0.465 times 10 to the power of 9. Okay, so we can factorize. So 3.4 minus 0.465 times 10 to the power of 9. So we will get the same answer as before. 2.935 times 10 to the power of 9. So this one is in standard form. Okay, so you can choose to use either method 1 or method 2. For me, this method is more simple. Okay, so you can choose either one. Both are correct.
So the question is, we have an internet plan of 5 gig for 30 days, and Tasha already used 4.15 to the power of 9 bytes of internet data in 20 days. So the question asks for the remaining data in megabytes. So the first step would be to write down the information that can help us. So we can just Google this stuff. 1 gig is equal to 1 to the power 10 to the power 9 bytes. 1 megabyte is equal to 10 to the power of 6 bytes. And 1 byte is equal to the 10 to the power of -6 megabytes. Alright, so let's make them in the same unit, because the question will eventually ask for answer in megabytes. Let's first change 5 gigs into the same unit of bytes. So 5 gigs is equal to 10 to the power of 9 bytes. 5 times 10 to the power of 9 bytes minus the information from the question, 4.15 to the power of 9 bytes. So using one of the law of indices, because the base power is the same, we can just directly subtract them. Then we will get 0.85. You guys can just subtract this number, and we will get 0.85 times 10 to the power of 9 bytes. And finally, they ask for a unit of megabytes. Convert this number into megabytes by multiplication. So, basic law of indices. Just subtract this number, 9 and 6. 9 minus 6 is 3, so final answer is 0.85 times 0 and times 10 to the power of 3. That would be in units of megabytes. To make it better form, we can just move them to the right by 3 decimal places, because we have 10 to the power of 3. So this will be to the right by 3. 1, 2, 3. So we will have 850 megabytes. So this is also acceptable answer. This is also acceptable answer because both of them are in units of megabytes.
Okay, number 4, given the mass of the moon 7.346 times 10 to the power of 22 and the mass of the earth is 5.972 times 10 to the power of 24. So given the mass of the earth is n times the mass of the moon, you find the value of n. Give your answer correct to 4 significant figures. Okay, so from this sentence we can change to next sentence. So the mass of the earth. The mass of the earth is n times the mass of the moon. So n times the mass of the moon, 4, 6 times 10 to the power of 2, equal to the mass of the earth. 5.972 times 10 to the power of 24. So n, the value of n is the mass of the earth per the mass of the moon. So 5.972 times 10 to the power of 24 per 7.346 times 10 to the power of 22. So we can use the calculator to get the value of 5.972 divided by 7.346, which is 0.8130 times 10 to the power of 24 divided by 10 to the power of 22 by using the second law of indices. So the index we can subtract. So 10 to the power of 24 minus 22, which is 2. So this is 4 significant figures already. So you can stop here or you can change to single number. So single number, we have to move 2 steps to the right. So 1, 2. Okay, the answer is 83.30. 4 significant figures. If you put 81.3, the value is equal, but not 4 significant figures. Okay, 81.3 is only 3 significant figures. So zeros after decimal is significant. So 81.30 acceptable. Okay, thank you.
Okay, n is 81.30. If n is an integer, n is 81. 81 is 2 significant figures.